Lesson: Predictive Analytics Using AI Models. Predictive analytics using AI models is an integral part of modern data analytics, providing businesses and organizations with the ability to forecast future trends, behaviors, and events based on historical and current data. By harnessing machine learning algorithms and statistical techniques, predictive analytics offers actionable insights that can drive strategic decision-making and improve operational efficiency. Central to this process is the selection and application of practical tools and frameworks that facilitate the development and deployment of predictive models. One of the foundational aspects of predictive analytics is the ability to discern patterns from data. This begins with data collection and preprocessing, a critical step that ensures the quality and relevance of the data used in model training. Data cleansing involves handling missing values, outlier detection, and normalization, which are essential for the integrity of the predictive models. Python libraries such as Pandas and NumPy offer robust functionalities for data manipulation and preprocessing, making them indispensable tools for data scientists. Once the data is prepared, the next step involves selecting the appropriate machine learning algorithms. Among the most popular are regression algorithms for continuous data prediction, classification algorithms for categorical data, and clustering algorithms for grouping similar data points. Linear regression, logistic regression, decision trees, and k-nearest neighbors are examples of algorithms that can be implemented using frameworks such as scikit-learn, which provides a wide range of tools for model development and evaluation. The application of these algorithms can be demonstrated through a practical example: predicting customer churn in a telecommunications company. By analyzing customer demographics, usage patterns, and service interactions, the company can build a predictive model to identify customers at risk of leaving. The implementation involves using historical data to train the model and then testing its predictive power on new data. Techniques such as cross-validation and hyperparameter tuning are critical at this stage to ensure model accuracy and generalizability. Incorporating AI models into predictive analytics not only enhances accuracy, but also introduces the ability to handle vast amounts of data efficiently. Deep learning models, particularly neural networks, have gained prominence due to their capacity to model complex patterns and interactions. Frameworks like TensorFlow and PyTorch enable the creation of sophisticated neural network architectures tailored to specific predictive tasks. For instance, convolutional neural networks are particularly effective in image recognition tasks, whereas recurrent neural networks excel in sequential data prediction, such as time series forecasting. A case study that illustrates the power of predictive analytics is its application in healthcare for early disease detection. By leveraging patient data, including medical history, genetic information, and lifestyle factors, predictive models can identify individuals at high risk of developing conditions such as diabetes or cardiovascular diseases. This proactive approach allows for targeted interventions and personalized treatment plans, ultimately improving patient outcomes and reducing healthcare costs. The deployment of predictive models into real-world applications necessitates considerations of scalability and integration with existing systems. Cloud-based platforms like Amazon Web Services and Microsoft Azure offer scalable infrastructure and services such as AWS SageMaker and Azure Machine Learning, which facilitate the deployment and management of machine learning models at scale. These platforms provide tools for automating model training, evaluation, and deployment, streamlining the process of bringing predictive analytics solutions to production. To ensure the successful implementation of predictive analytics, it is crucial to address potential challenges such as data privacy and ethical considerations. The use of personal data in model training requires adherence to regulations such as the General Data Protection Regulation to protect individual privacy. Moreover, ethical considerations involve ensuring that predictive models do not perpetuate bias or discrimination, which can be mitigated through techniques such as fairness-aware machine learning and bias detection. Evaluating the performance of predictive models is another critical component, involving metrics such as accuracy, precision, recall, and F1 score for classification tasks, and mean absolute error and root mean squared error for regression tasks. These metrics provide a quantitative assessment of model performance, guiding further refinement and optimization. Visualization tools like Matplotlib and Seaborn play a key role in interpreting model outputs and understanding feature importance, contributing to more informed decision-making. In conclusion, predictive analytics using AI models represents a transformative approach to data-driven decision-making. By leveraging advanced tools and frameworks, professionals can develop predictive models that offer valuable insights and drive strategic initiatives. Through practical applications and real-world examples, the potential of predictive analytics is realized across various industries, from telecommunications to healthcare. As data continues to grow in volume and complexity, the role of predictive analytics will only become more pivotal, underscoring the importance of mastering these skills and techniques.